Welcome to Institute of Quality and Reliability. Hi, this is Hemant.
Reliability Sampling Plans Part 2 PRST and Fixed Length Plans. In part 1 of this video, we have explained basic concepts in sampling plans. In this part 2, we will discuss fixed length and sequential test plans. We will refer Mill Handbook 781 for reliability test methods to explain these plans. You can do a Google search for Mill Handbook 781. And when you do that search, you will find this link on Bible.com. If you click on that link, you will find many useful mill standards. You can browse through the list and find out the standard that you want. We can locate the Mill Handbook 781A and then download the same. So here is the link to Mill Handbook 781A, and then we click on that and download the standard, and this is the standard Mill Handbook 781A. This is the handbook for reliability test methods, plans and environments for engineering, development, qualification and production. After the contents pages, you can find the definitions in the standard. For example, you will find definition of consumer's risk, producer's risk, discrimination ratio D, and many other definitions. Let us now look at the section on standard test plans. Note that the standard test plans are based on underlying assumption that the distribution of time between failures is exponential, that is, with constant hazard rate. There are 4 categories of test plans listed in the standard: Probability Ratio Sequential Test Plans or PRST plans, short-run high-risk PRST plans, fixed duration test plans, and all equipment reliability test plans. Let us see the symbols used in the standard. Theta 0 is the upper test MTBF, which is the acceptable mean time between failures. Theta 1 is lower test MTBF, which is contractually agreed minimum MTBF to be demonstrated. Then the discrimination ratio D is defined in the standard as D is equal to theta 0 upon theta 1. Alpha is the producer's risk and beta is the consumer's risk. Let us understand some more details about PRST plans. As discussed before, these are based on Mill Handbook 781. PRST plans will accept material quickly with very high MTBF or reject material quickly with very low MTBF compared to fixed length plans with similar risks and discrimination ratios. PRST plans assume constant failure rate. That is, the underlying distribution of times between failures is exponential. Failures tracked against test time in multiples of minimum specified MTBF theta 1. Tests are based on ratio of acceptable MTBF theta 0 to unacceptable MTBF theta 1. Test is continued until decision lines or truncation lines are crossed. X-axis of PRST plans is test time, but it is in multiples of theta 1. Remember, theta 1 is the lower acceptable MTBF. Y-axis is the number of failures. The green line is the accept line, below which we will conclude that the equipment meets reliability requirement and accept the equipment for the given reliability. The red line is the reject line, above which we will reject the equipment and our conclusion will be it does not meet our reliability specifications. The test cannot go on infinitely, therefore truncation lines are provided in the standards. Now consider an example of an equipment which is being tested. Let us say it is tested up to time 1.5 theta 1 and it encounters the first failure, that is r is equal to 1. As the line is within the boundaries of reject and accept, we continue testing further, and the test is continued until time 3 times theta 1 when the second failure occurs. But observe that the line is still within the boundaries of reject and accept, and we continue to test further. So further test is continued up to 4 times theta 1 test time when the third failure occurs, but still within the boundaries, so we continue to test further. At time is equal to 6 times theta 1, the line crosses the accept line and now it is below the accept line, that is the green line. Therefore, the equipment will be accepted at this point of time. So the total test time here will be 6 times theta 1. Let us see another example. This is the PRST plan. We start test of an equipment and it continues up to 1 theta 1 and the first failure occurs. Then it continues testing. At 1.5 theta 1, second failure occurs. At about 2.5 theta 1, third failure occurs. The fourth failure occurs at about 3 theta 1 and the fifth failure occurs at about 3.5 theta 1, and at that point it crosses the red line, and therefore we must reject the equipment and we must conclude that it does not meet our specified reliability and MTBF requirements. So what are the equations of the accept and reject lines on the PRST plans? The accept line is defined by the equation number of failures R equals A plus BT. What are the values of the constants A and B? A is equal to ln B upon ln D and B is equal to 1 upon theta 1 minus 1 upon theta 0 upon ln D, where D is the discrimination ratio theta 0 upon theta 1. We will see what is the value of the constant capital B shortly. Now let us look at the equation of the reject line, which is R is equal to C plus BT, where C equals ln capital A upon ln D. So what are the values of capital A and capital B constants? Capital B equals beta upon 1 minus alpha, where beta is the consumer's risk and alpha is the producer's risk. Value of A is equal to 1 minus beta upon D plus 1 upon 2 alpha D, where D is the discrimination ratio theta 0 upon theta 1. I am using Mill Handbook 781 as the source for this information. I am showing an example of PRST plan from Mill Handbook 781. This is plan 2D, and you can see at the top of the plan that the discrimination ratio D is 1.5:1. On the x-axis you will see total test time in multiples of lower test MTBF theta 1, and on the y-axis you will have the number of failures. The Mill Handbook also shows the operating characteristic curves for each plan. As an example, I am showing operating characteristic curve OC curve for plan 2D, which I have shown you earlier. Remember, discrimination ratio is equal to theta 0 upon theta 1, and for this plan the discrimination ratio is 1.5. Therefore, theta 1 is equal to theta 0 upon 1.5, that is 0.66 theta 0. On x-axis you will see both the scales in multiples of theta 0 as well as theta 1. At time is equal to theta 0, you can see that the OC curve shows probability of acceptance of 0.8. Therefore, the alpha risk is 1 minus 0.8, that is equal to 0.2, that is 20%. At time is equal to 1 theta 1, that is 0.66 theta 0. The probability of acceptance is 0.2, and this is the beta risk of the sampling plan, or 20%. Mill Handbook 781 also provides for many fixed length test plans. The fixed duration tests offer a distinct advantage for program planning, namely prior knowledge of test duration, which permits program planners to perform trade-off studies between test duration consumers and producers risk theta 1 and theta 0. These are the test plans mentioned in Mill Handbook 781. The last three test plans are high risk test plans. As you can see that the alpha and beta risks are approximately 30% in the last three plans. Suppose we choose plan 15D for our testing, and let us say that our lower test MTBF or lower acceptable MTBF is 200 hours. The alpha risk and beta risk of this plan is approximately 10%. The precise alpha risk is 9.4% and precise beta risk is 9.9%. Discrimination ratio is 3 and test duration is 9.3 times theta 1. So if theta 1 is 200, then the test duration will be 9.3 into 200, that gives us 1860 hours of test. If we get 5 or less failures during this test, we will accept the equipment. If we get 6 or more failures in the test, we will reject the equipment. Obviously, if we get 6 or more failures before the test is complete, we can reject the equipment. But for acceptance of the equipment, we will have to continue the test until full 1860 hours. Thanks for watching this video. Hope you found it worth watching. Please subscribe to Institute of Quality and Reliability channel if you want to watch more videos on reliability engineering, Six Sigma and statistical quality control. Click on the subscribe and bell icon to get notified for future videos.